record, right? And
Good morning, sir.
yes, good morning. All right, so let's move on. So these are some formulas for the common 3D shapes. I'm going to have to mute some persons because I'm hearing some feedback. All right, I'm sorry. All right, so yeah, let's move on now. So we have a sphere here, and we have a cube, rectangular prism, a right circular cylinder. And we said yesterday that if I'm going to give you any of these to calculate, I'm going to provide you with a formula, right? So we have our first object here, and this is considered a sphere, right? A sphere, and it has a diameter of 2.6. Now, tell me, what is the diameter? If anyone remembers the diameter, what is the diameter exactly?
Sir, like when you split the
The
shape
length.
in half, sir.
Right, we're getting somewhere. We split the shape in half.
So the length, when you split the shape in half, how much is measured?
Right, so we split the shape in half. Let's do that. Now, diameter will be the distance from, this is A and this is B. So it will be the distance from A to B, right?
Yes, sir.
Yes, sir.
Right, now in our formula, it says R. It doesn't say diameter. What is it saying now? What does it want?
Pi r cubed.
So what is the R? What is it looking for?
The radius.
Radius.
Right, so what is our radius?
Half of the diameter.
All right, so half of the diameter. So in order for us to find the radius, R, this is equal to D over 2. And we said D is
2.6.
2.6 in this case. So let's put that in 2.6 divided by 2. And we get, what do we get here?
1.3.
1.3.
Yes.
Sir, I'm lost.
Question?
Yes.
All right, so we put in our 1.3 value here, and we get our final answer. All right, our final answer. Let's try.
Sir,
I hear a question.
sir, is this going to be recorded, sir?
Yeah, it's currently recorded, and it will be posted on Google Classroom. All right. Okay. Let's move on. So let's work this out. So we have V equal 4 pi over 3. Remember, Mr. Treasure is going to provide you with the formula if you're going to do this question. So we break this down, 4 over 3 times pi, right? And what do we say go here?
22 over 7 or 13 point something. I don't remember.
Right, that's for pi, right? But what are we saying goes into the
2.6.
2.6?
1.3.
Right, 1.3.
1.3.
Right. And let's break this down even further. So we have 4 over 3. And what we say our value for pi is?
22 over 7.
22.
22 over 7, sir.
Right. And then we find what is this? What is this right here? 1.3 cube. How do we get that?
The radius.
Right. So how do we find the value of this guy?
1.3 times 1.3
So
times
the
1.
diameter divided.
No diameter. Right. So as the person said, 1.3
Yes,
You
times
multiply
1.3 times
1.3
Right. So we're
times.
looking at our exponent up here. So if we had 1.3 to the 2, what would that be?
Yes, sir.
What would that be?
3.9.
No, that's the same. Let's work over here first.
How much is it?
Right. So over here, let's look at this. If we have 1.3 squared, what would this be? 1.3 times what? 1.3 times what? That's 1.3.
1.3.
Right. And if we had 1.3 to the 4, what would that be?
1.3 times 1.3 times 1.3
exercise
times
that.
Right.
1.3. 3.
Yeah, right. So
Nah, do it
1.3
later.
times 1.3 times 1.3. So it depends on our exponent, right?
Yes, sir.
Now we said our value for this again. What is our value for this? I heard somebody with it.
Sir, 3.9.
3.9. Let me just double check that.
Oh, that me not think that right.
Try it again.
Yes, sir.
Try it again. 1.3 times 1.3 times 1.3. What are we getting?
Sir, 2.197.
Right, 2.197. 2.197. All right, let's break this down even further over here. Right, let's break it down even further. So we have equal. So what? Let's do this here. So we have all of these in the same line, right? So let's just multiply them across. Right. So we have 4 times
23.
4 times
20.
22, right? What are we getting there? What is 4 times 22?
88, sir.
Right, times 2.197.
193.33.
Right. So 193.336.
28, sir.
0.336.
Right. Now let's do the bottom half. We have 3 times 7. What is that?
3 times 7 is
21.
21.
21. Right. So what is our final value for volume? Go again. Repeat. I'm not hearing. I'm breaking up. Hello. Hello.
Yes, sir.
Right. So what was the value for the volume is now?
Coming up, sir. Coming up.
Okay.
9.20.
Right. So 9.20, which is the same thing as our guy up here. So what is our unit? Is it 9.2 apples? 9.
Cube.
No, sir.
Right. So what is it?
I can go back that to me.
Okay, I will. What is our unit again?
Cube, sir.
Meter cube. Meter cube.
Sir,
Question? Here, a question.
I don't get the part. Sir, I don't get the part where put the 193.33.
Right, so that is our value down here. So we times 4 times 2 times 22 times 2.197. Yeah, so because all of them are in the same line, we times them. And all of these are in the same line, the 3 and the 7, we also multiply them. So we times 3 and 7 and we get 21. And we times 4 times 22 times 21 times 2.197 and we get 1.93. Right.
Sir, so all we have meter and not meter cube, sir.
Right. So it's meter cube. Sorry about that. Right. Meter cube. Somebody wanted me to go over it again?
No, sir.
Sir, I came late, sir, so you have to go over it back. Please.
No, I don't have to,
Exactly.
but I will.
It
All
will be
right?
posted.
It's okay. I'll do it over next time. Ask me kindly. All right.
Yes, sir.
All right. So we have our sphere here, right, and our diameter. Now, what is our diameter? Our diameter represents the distance from,
A to B.
right, from A to B. That's our diameter, right? And our equation, on the other hand, requires us, what is this requirement?
The radius.
Right. So I want the person who wanted me to go over to interact with me, right? Those who already understand, I'm asking you to give this person a try, okay? This
Yes,
person
sir.
a chance, all right? So yeah, who wanted me to go over it again? Is it Miss Johnson? All right, I'm not getting a response. All right, but I'll move on. Just the same. So we have our diameter and our radius. What is our radius here? I want the person who wanted me to go over to interact with me just to ensure that they're getting it right.
Yes, sir.
Right. So it's Miss Johnson, right?
Not Miss Johnson, sir.
Oh, Mr. Johnson. Sorry about that. So we have our radius is our distance from here into the middle, right? So that would be half of our diameter, right? I apologize for that, Mr. Johnson. So we have our radius and our diameter is d over 2, right? D over 2. So it would be 2.6, right? Because our diameter is 2.6. So it would be 2.6 divided by 2. So that would be 1.3. So are we good here?
Yes, sir.
Right. So now we move on to our volume. So we calculated the value for our r, our radius. Now we want to calculate the value for our volume. Right. So volume is 4 over 3 pi r cubed, right? And we have our value for r. Our value for r here, right, as 1.3 meters, right? We should put meters here. So we start to plug in, right? We plug in our values. So we plug in our 1.3 here, and we break this down, right? So it will be 4, right, times pi, which pi is 22 over 7, right?
Yes, sir.
Right, pi will be 22 over 7 times this. Now, what is our 1.3 cube? How do we represent this? How would you calculate 1.3 cube?
Yes, sir.
Johnson, are you hear me? All right. Let me just continue then. So 1.3, Johnson, are you hearing me?
Not so good, sir.
All right. Are you hearing me now?
Yes, sir.
Right.
But
So
you're breaking up a little bit.
right. So how would we calculate 1.3 cube? How would you do that? It will be 1.3 times 1.3 times 1.3, right?
Yes, sir.
Right. So we would get a final answer is 2.197. So we have 4 times 22, as our pi is 22 over 7, right, times 2.19. And then we multiply all of these and we get 1.93.336, right? And down here now we have 3 times 7. 3 times 7, so that would be 21. And
21.
divide them, and we have 9.2 meter cube, right? You have to remember your units for volume, right? So
Yes,
are we
sir.
understanding now?
Yes, sir.
All right. All right. So any questions before we move on, guys?
No, sir.
No, sir.
All right. So we're moving on now. This is our last thing before we go. We should be able to complete this in 5 minutes. So to calculate the volume of an irregular shaped object, right? Irregular shaped object. All right. So in order for us to calculate the area of a irregular shape object, the area, we would break it down into pieces that we were able to identify. So figure 1, figure 2, and figure 3, and we name them respectively. But it is much more difficult when dealing with the volume, right? We have to use a separate method, right? So moving forward and calculating the volume of an irregular shaped object, say we want to calculate a volume of a stone. This stone here, this does not look like a cube, neither does it look like a triangle, no, a prism or a sphere, right? It doesn't look like a sphere, right? A sphere looks more circular, right? But this guy looks like a stone, right? There's no formula here that could be used to calculate this. So it's a separate method. So in order for us to calculate the volume of an irregular shaped object, we need a container that has a familiar 3D shape, right? So we can be able to determine the volume of that, right? So a measuring cylinder.
Sir, that is not the regular shape, sir.
Go again. Our stone here. Our stone. That's what you're referring to. All right. I'm not hearing a response. All right. So I'm not hearing it. Repeat. All right. You can send a message in the chat. Yes, send a message in the chat, because I'm not really hearing it. Right. All right. So
That is the perfect one.
so we will have a measuring cylinder with some water, right? This is what we commonly use to determine the volume of an irregular shaped object, and we use the displacement method, right? This is very important. Displacement method. So whenever we put an object in water, the water is displaced, right? Water is displaced, and as a result, it seems as if the water has more volume, right? But the only reason why it has that is because of the addition of that object. So the volume of water in milliliters displaced is equal to the volume of the irregular shaped solid, right? The volume of this irregular shape. So the amount of water that is displaced, that is our volume, right? And we must remember this, that 1 centimeter cube approximately equals to 1 milliliters. So 1 centimeter cube is used to measure solid, right? The volume of a solid, while milliliters is usually used to measure the volume of liquids, right? Just bear with me for